In this video, I'm going to go over how to do 2.3 daily problem for my Applied Calculus 1 students. Okay. So find the equation of the tangent line to the graph of y equals x squared times natural log of 5 plus 3x to the fourth power at x equals 1. So equation of a tangent line problem, we always need to find that x value and y value. Oh, sorry, x value is given, x is just 1. But let's find the y value. What is y going to be? If I plug in 1 into this function, I will get 1 squared times natural log of 5 plus 3 times 1 raised to the fourth power. Okay, so what's that going to be? That is 1's just 1, natural log of 5 plus 3 times 1. So y is simply natural log of 8. So we found the y value. This is the y value. So I'm going to need these things later on. Hold on. So I need my x. I need my y. And all I need is the slope now, right? I need to find the slope. To find the slope, we need to find the derivative and then plug in x equals 1. So let's find the derivative. So if y equals x squared times natural log of 5 plus 3x to the fourth power, this is a product. Whoopsie, this is a product. So I will use a product rule. Okay. Oh, this is so slow. Oh no, it's gone now. Oh my goodness. All right. So much is gone. All right, hold on. X is 1. Y is natural log of 8. And I was going to just do the product rule for my y. And I'm doing that to find the slope of the tangent line. So y is x squared times natural log of 5 plus 3x to the fourth power. That means doing my product rule. This is where I stopped on my first attempt. Why isn't this working? Product rule where f is x squared, right, the first, and f prime is 2x, g is natural log of 5 plus 3x to the fourth, that right there. And now we have to take the derivative of that. And that is going to be, you saw how I did this on the lesson videos. Whatever argument is going to be the denominator. So we will first have 1 divided by 5 plus 3x to the fourth power. But don't forget to multiply this by the derivative of that argument, ddx of 5 plus 3x to the fourth power. So if I simplify this, or actually take the derivative, I will get 1 over 5 plus 3x to the fourth. Well, hold on. If I take the derivative of this 5 plus 3x to the fourth, wouldn't that be just 12x to the third power, right? Because the 5 is gone. I can probably just put that on top of this fraction where the 1 used to be, because 1 times 12x to the third power is just 12x to the third power. So that is g prime. Okay, so I got all the pieces I need to do my product rule. So let me come down here and write down the product rule real quick. Okay, product rule is first times the derivative of the second plus second times the derivative of the first. And that is how we will find y prime. Okay, so y prime is, one step at a time, hold on a second. I need to do f. And f is x squared. So I'll do x squared first. And this is getting multiplied by g prime, which is 12x to the third power over 5 plus 3x to the fourth. So let me write that next to it. Times 12x to the third over 5 plus 3x to the fourth. I close the parenthesis and we're going to do plus. All right, let's see what's next. Next is g, and g is just that natural log expression. Natural log of 5 plus 3x to the fourth. And we're multiplying this by f prime. And f prime is 2x. Technically, we found the derivative. We just now need to simplify this. Or if you want to plug in 1 in this form, that's fine too, really. But I should be able to simplify this a little bit further. So maybe I'll just go ahead and see what we can do. Y prime is, now here's what I notice, you guys. I see there is x squared and x to the third power. I can multiply them, right? I can multiply these and get 12x to the fifth power all over 5 plus 3x to the fourth power. And I guess this is okay, but I think I will bring this 2x in front. And why would I do that? Just the way that I want to write it, I guess. I'll just write that 2x in front. Really doesn't make any difference, but still. Plus 2x. And then I'll do natural log of 5 plus 3x to the fourth. So I found the derivative. And why did we do all this work? Well, because we wanted to find the slope. Look, the slope was missing. I need my 3 pieces. I have my x, I have my y, but I don't have my m. So to find m, you will now plug in x equals 1 into this derivative function. All right, let's plug in 1 in here. So slope is 12 times 1 to the fifth power over 5 plus 3 times 1 to the fourth power plus 2 times 1 times natural log of 5 plus 3 times 1 to the fourth power. And we just need to simplify this. And this isn't going to be all that pretty, but we can still simplify it as far as we can. So the first fraction will become, 12 times 1 on the numerator. So that's just 12. Look at the denominator. We have 5 times 3 times 1, right? So that's just going to be 8. And I'll have plus 2 times natural log of. Now let's see what this will give us. Isn't that just 8? Okay, so that's just 8. So hey, I'm sorry, it's a little ugly, but that is a slope. But you know, I may be able to just get the decimal of this. And I hate to get the decimal approximation in the middle of the problem, but I don't want to work with almost a binomial looking. It's not a binomial, it's just a constant number, but still, I'll just get a decimal of this because it's an ugly looking fraction. All right, hold on. Let me go over here and type in. What was it? Guys, it's 5 o'clock in the morning. I'm so sleepy still. 2 times natural log of 8. Okay, so I'll copy that down. 5.65, and I want to be accurate. So how about I write a couple more decimal? 5.65883. That's probably good enough. Okay, so I got all the pieces I need. And I think unfortunately this problem wanted us to write the equation in slope-intercept form. Oh, who still does that? Yep. Oh, actually, you know what? They never said that. They never said write the equation of the tangent line in slope-intercept form. Didn't they? I thought they did. I thought they did. I'll write it in slope-intercept form, but hold on. Let me copy this down there, or maybe I can just write it. Right, look. X is 1, and y was natural log of 8. Okay, all right, let me plug it into the point slope form. I'm just doing really slow, that's why it's not supposed to be this long, but y minus y1 equals m times x minus x1. All right, let's see what we have. So y minus natural log of 8 equals 5.65883. It's ugly, but it's actually better than this, isn't it? All right, times x minus 1. Okay, so far so good. It's probably not good to round in the middle of a problem, but hey, who cares? This is okay. So I'll distribute first. Y minus natural log of 8 equals, if I distribute, I will get 5.65883x minus 5.65883. And all I now need to do is to add natural log of both sides, and that will be my y-intercept. So y equals, and hold on, I think they wanted us to round the answers to nearest hundredth. There's no direction like that. I'll just round however I like then. Okay, so I'll say 5.659x. My note-taking app slowed down a little too much. Let me restart this. Okay, 5.659x. And then I need a calculator because I am now about to type in this part to figure out the y-intercept. Okay? Well, hold on. Hey, I think I remember. I have the original form of this here. Okay, so I'm gonna type in the negative of it, the negative 5.65888, and then I'll add the purple part, natural log of 8 here. Natural log of 8. If I do that, I get the y-intercept of negative 5.79. Let me write that down. Negative 3.579. And that is what I will do. That is how we write the equation of the tangent line. We had to do the derivative of natural log function, but finding the x, y, and m to write the equation of the line is still the same thing. So I guess this part was it was the new idea, right? Using the product rule and using the derivative of natural log of u. But I hope this video was helpful. I will be getting some perfect submissions, I guess, this week. Well, that's all good. I'll go ahead and process video now.